Question number 6. This question is about gold and compounds of gold. 6.1 is an AO1 question. In the alpha particle scattering experiment, alpha particles are fired at gold foil. Alpha particles are positively charged particles. Figure number 5 shows the results. If you look here, this is the gold foil. Alpha particles are fired at the gold foil. Most of them are passing straight. A little bit deflection is coming here. Even some of them are coming back. The student must have the good knowledge about this experiment, which is done by Rutherford. Which two conclusions can be made from the results? Tick two boxes. Atoms are balls of positive charge with embedded electrons. This is the concept of plum pudding model. So this is a wrong option. Atoms are tiny sphere that cannot be divided. This is from the John Dalton atomic theory, which is also an incorrect information. Atoms have a positively charged nucleus. This is a correct option. Mass is concentrated in the nucleus in the center of the atom. This is also a correct conclusion from this experiment. The last one is highlighted. Students sometimes make a mistake. Neutrons exist within the nucleus. This is a correct option, but this is not a correct option from this experiment because the neutron was discovered very late after this experiment. So we can't take the last option. So the last option is also incorrect option regarding this experiment. 6.2 is an AO2 question. The gold foil is given here as a sample. The thickness of the gold foil is 4 into 10 raised power minus 7 meter. And in the thickness there are almost 2400 atoms are present. Consider this is a gold foil and the thickness of the gold foil is 4 into 10 raised power minus 7 meter. And number of the atoms present here, there are 2400 atoms. So this question is actually from the size and the mass of the atom. In this length, the number of atoms are present 2400. What is the diameter of one gold atom in meters? We need to find the length of one atom. Give your answer up to 3 significant figures. For this length, we have 2400 atoms. And if we need to find for one atom, we want to find the length of one atom. Let's see the model answer. In this model answer, we have the length and the number of atoms. So length ratio number of atoms. If this is the length, there are 2400 atoms. So this length 2400 atoms are there. If one atom is present, what is the length of this atom or diameter of this atom? For one atom, we need to find the length or the diameter of that atom. So we are going to use ratio and proportion method. This x is going to multiply with the 2400 and 1 will multiply with this value 4 into 10 raised power minus 7. We did it here. And 2400 is going to divide this side and we get this answer. By using the calculator, our answer is 1.666 10 raised power minus 10. But the demand of the question is up to 3 significant figure. So we will take the first 3 significant figure 1, 2 and 3, and this digit is greater than 5. We're going to increase this number. It becomes 1.67 10 raised power minus 10 meter. The answer is 1.67 10 raised power minus 10 meters. 6.3 is an AO2 question from the topic of balanced chemical equations and conservation of mass. We see from the balance equation that AU reacts with Cl2 makes AuCl3. Calculate the mass of chlorine needed to react with 0.175 grams of gold. Give your answer in milligrams. Whereas relative atomic masses of gold and chlorine are already given here. This question has two methods. Either we need to convert the moles in our balance equation into mass, then it will become very easy for the students and they need to use ratio and proportion method, or they have to convert the given mass into moles and they have to find the number of moles first, and from those moles they need to convert those moles into grams. Let's see the model answer. We know that the gold has 2 moles, chlorine has 3 moles, but chlorine is existing as Cl2. So for chlorine, we know the formula for the moles is equal to mass over AR, or number of moles is equal to mass over MR. First, we are going to find the mass of chlorine. Number of moles of chlorine are 3, and we're going to substitute here. Mass of chlorine is unknown, and AR is 35. The reason is chlorine has atomic mass of 35.5, but this is for one chlorine. In our formula, we have Cl2. Therefore, we need to multiply this value by 2 to make Cl2. So 35.5 into 2 becoming 71. 71 will go other side. We will get 213 gram of the mass here. Similarly, we will use the same method for the gold. Moles is equal to mass over AR, relative atomic mass. We can see that number of moles in the balance equation, they are 2, is equal to mass over relative atomic mass of gold, that is 197. If we are going to multiply this side, and the mass of the gold according to this balance equation, that is 394. The question is, we need to find the mass of chlorine if 0.175 grams of gold will react. So we try to make the relation between gold and chlorine. Gold is 394, we got here. Mass of chlorine is 213, we're going to use it here. Whereas 0.175 grams of gold is given here, we use here. And the mass of chlorine related to 0.175 is unknown, that we use it as an X. We use the ratio and proportion method in method number 1. This X will time with 394. 0.175 we're going to multiply with 213. And our answer by using the calculator is 0.0946 grams. But we need to convert this value into milligrams. We know that 1 gram is equal to 1000 milligrams. So we are going to multiply this value by 1000, and the decimal will move 3 digits on the right, and it become 94.6 milligrams. The method number 2 is given here. We need to convert the given mass of the gold into moles, and the mass of the gold is 0.175 grams, and we know the formula for the mole is equal to given mass over AR. Given mass is 0.175 and AR of gold is 197. So number of moles are 0.00888 moles. Now from the balance equation, we know that the balance equation in the form of moles. We know that there are 2 moles and 3 moles between gold and chlorine. So we take the ratio between them, 2 moles and 3 moles. We converted this mass into moles also. So the moles of the gold are 0.000888 moles, but the number of moles of chlorine are unknown. First, we will convert this value into moles, or we will find the moles of chlorine first. Then we're going to use this formula to find the mass of the chlorine. This x is going to multiply with 2 and this value will multiply with 3. So we have 2x is equal to 3 into 0.000888. We want to make x as a subject. This 2 will go on the other side and it will divide. The answer is 0.0132 moles. But we need to find the mass of chlorine. We have the formula number of moles is equal to mass over AR. We know that these are the moles of chlorine. We're going to substitute here. AR of chlorine 35.5 times by 2 because it is Cl2. And this is going to multiply this side. We will get the mass of chlorine. Now this mass is in grams. We need to convert into milligrams. We're going to time this value by 1000 and we get 94.57 milligrams or 94.6 milligrams.